Today's problem was submitted by a viewer, and it says, show that the equation x cubed plus x squared minus ax minus 1 equals 0 has three distinct real roots if a is strictly greater than 1. Okay, ax cubed plus x squared minus ax minus 1 equals 0. And we're going to assume a is greater than 1, and we need to show this has three distinct roots. I wonder, do I want to take like a totally analytical approach to this? Take some derivatives, try and sketch the graph of this, find minima, local maxima, that kind of thing. That might be a good way to do it, right? Just we know it has at least one real root, right? Any cubic equation of real coefficients will always have at least one real root. If I find a local minimum and a local maximum and show that they have opposite sign, then that's enough. So I think that's what I'll do. Okay, so let's call this cubic thing f. I don't know if this approach will work, but it's something to try. So f prime of x is equal to 3x squared plus 2x minus a. And I'm going to set this equal to 0. So when this is equal to 0, x is equal to negative 2 plus or minus the square root of 4 plus 12a divided by 6. The question is, do I really want to substitute this back into the cubic? That's pretty disgusting, isn't it? Maybe something about I don't like that they use this letter a. I want a to be one of my roots. X minus n, x minus m, x minus k. That's x cubed minus n plus m plus k x squared plus nm plus nk plus mkx minus nmk is equal to 0. So n plus m plus k is negative 1, and nmk is negative 1. I don't think this is a great way of doing this. What about So what about plotting? Or what about... if I can just find... okay. What's a rough sketch of this thing going to look like? It's going to be like this, and it's going to be like this. When x equals 0, it goes through -1. So if I can find a negative value of x where the function is positive, I'm done. In fact, not only is it at a value of -1 there, but it's decreasing through that point. So if I just substitute some negative values for x, how about x equals -1? This is equal to a minus 1, which is positive. Okay, great. Right, because we're told we only care about doing this when a is greater than 1. So when x is equal to -1, the value of the function is slightly higher. So it has to go through there. I don't know if it's increasing or decreasing or what, it doesn't matter, but it goes through that point, which means it also must come back down from that point there. And we have 2 negative roots there, and there's going to be a positive root over here. Yeah, that's enough. The fact that f -1 is greater than 0 implies 2 negative roots. Well, f -1 greater than 0 and f -infinity is equal to -infinity, and f of 0 is equal to -1, which is less than 0. So, you know, this is above, these are both below. There must be 2 points where it crosses then. You know, one to the left of -1 and one to the right of -1. And again, combined with the fact that as x goes to positive infinity, this goes to positive infinity, we'll have another root somewhere. So that's enough. You know, I never, my first instinct is rarely to just substitute individual values of x into a polynomial. You know, I guess in quote real problems, that's not going to work, but that's fine here, I guess, with what it's asking for us to do. Yeah, if I think of anything else to say about this one, I'll let you know and put it in the video. Thanks for the submission, and thanks for watching.